Okie dokie, in this video we'll be covering 1014 quiz 3 practice problems. So starting with number 1, solve the equation, simplify your answer if possible. So we're just going to expand what we can here. Let's distribute the -4, distribute a -1, and we will get -4p minus 4 minus 3 equals -5 minus p and plus 4. A -1 times -4 is a +4. Let's see what we can do here. We can add, let's add 4p to both sides, mainly to get rid of that and to give us a nice -1 plus 4, so 3p over here. We can do -5 plus 4 and get -1. We can do -4 minus 3, get -7. So just start chipping away at it. And we will add the 1 to get -6 equals 3p. Divide by 3 and get p equals -2. So the solution set is -2. That was number 1. Let's do number 2. For a recent year, the cost C in dollars for in-state tuition and fees for X credit hours at a public college was given by this equation. Determine the cost to take 13 credit hours. So that would just be C of 13. It's the cost of 13 credit hours, which means we just plug in 13 in place of X because X represents credit hours. So this is a good job for, what's it called, Apple Notes. So let's have a little fun with it while we're working this out here. 161.85 times 13 minus 97. 2007.05. So that is the cost of taking 13 credit hours. That seems pretty reasonable. Let's keep it going. If a student spends 1197.8, how many credit hours did they take? Okay, anyone want to take a guess? I mean, 13 was over 2,000, so I'd say about half of 13, but not quite half. So I'm going to say 7. Half would be 6.5, so I'm rounding up to 7. So let's see. How can we check for sure? Well, we're going to set this equal to the cost and then solve for the credit hours or solve for X, right? So we set it equal to 161.85 and X and minus 97. Because we're solving for the number of credit hours, solving for X when we're given the cost. So we set the cost equal to the cost. We add 97, we get 1,294.8 equals 161.85. We divide by 161.85. That's a nice clean little answer there of 8. I was 1 off from my initial guess. Not too bad. Okay, so that is number 2. Number 3, solve the equation. What do we notice here? We have fractions being added. We have not common denominators here. So maybe let's get a common denominator first so that we can add things and then ultimately solve for Q. So what we can do is think about if this denominator has a 3, this one has a 3 and a Q, this one just has a Q, then maybe our goal here is to make all of them have 3Q because 3Q already has pieces from the other 2. And so to make it so that these other fractions have a 3Q, well, this first one already has a 3, so it needs a Q. The second one has a Q, so it needs a 3. And what we multiply at the bottom, we have to multiply up on top here, because it's like we're multiplying by something divided by itself, which is like multiplying by 1. So it's not changing the value, but it's still allowing us to achieve our goal of getting a common denominator. So we multiply Q times 1, we get Q. We have an 8. We have 7 times 3, 21. And now all of this is over 3q. Okay, this is kind of interesting. So, I mean, at this point, really what's going to make these equations equal to one another, notice, like, really it's just q plus 8 over 3q and 21 over 3q. So the thing that's going to make these equations equal really is if q plus 8 is equal to 21. It's like just make the numerators equal to each other. Because notice the denominators are already equal. So it's really just a matter of whether q plus 8 will be equal to 21. And so we solve for q and we get 13. And so I think just the solution set is 13 here. So it's a finite set, and that solution set is 13. All right. Number 4 is solve the equation. Similar approach. We look at our denominators. We have k minus 5, we have a k plus 5, and we have a k squared minus 25, which could maybe be incorporating these other two. How can we check? Well, let's factor it. So k squared minus 25 can be factored into, you guessed it, k minus 5 and k plus 5. So this denominator already has the other two denominators, okay? So what does that mean? Well, we don't have to multiply this fraction by anything, but we can multiply this far left fraction by k plus 5 over k plus 5, so that its denominator has not just k minus 5, but also k plus 5. And then this second fraction, I'm not going to squeeze it in there, but I'm going to write it over here. We're going to multiply by k minus 5, because it already has the k plus 5 in the denominator. So now let's try to visualize this. We're going to do our multiplication. So 2 times k and 5, we get 2k plus 5 minus 1k minus 5. So I'm going to do minus, in parentheses, k minus 5, just to make this a little visually easier first, over our common denominator of k minus 5, k plus 5, because again, that's what we still have on the other side. We have k minus 5, k plus 5. So we have common denominators now. So really it's not a matter of whether these match up, it's a matter of whether the numerators match up. So let's keep simplifying. We have 2k plus 5. We have minus k, but minus 1 times negative 5 is plus 5 equals 24. 2k minus k is k. 5 plus 5, 10. Equals 24. We subtract 10 and we get k is equal to 14. 14 is our finite set. Okay, that was number 4. Number 5. Dexter has a truck that gets 32 miles per gallon on the highway, 20 in the city. The amount of gas used is A. It's given by this equation here. C is number of city miles, H is number of highway miles. If Dexter uses 2 gallons on a trip where 25 miles were driven in the city, how many miles were driven on the highway? In other words, what is H? They've given us A, and they've given us 25. So we just plug those in to the equation. And we solve for H. Okay, let's see what we got. We want to get H by itself. So let's get rid of the stuff that's furthest away from it first. We have 25 times 1/20. That's just 25 over 20, which reduces to 5 over 4. So we have 5 over 4 plus 32, 1 over 32h equals 2. Let's subtract the 5 over 4. 2 is equal to 8 over 4 minus 5 over 4. 8 minus 5 is 3 over 4. So we have 3 over 4 equals 1 over 32h. We get h by itself by multiplying both sides by 32. And when we do so, that goes away, so we're left with h. When we multiply 32 times 3 over 4, think about it like this. 32 over 4 is 8. So then you have 8 times 3. And that would be 24. So this guy drove 24 miles on the highway. All right. That was number 5. Here's number 6. Identify the equation as conditional, contradiction, or identity, then give the solution set. Okay, so I don't really know yet. Let's see. I'm going to distribute the 3 first and kind of act like I'm solving right away. So let's distribute the 3. We get 24 minus 3 times 7, so 21x, and then minus 6 equals, and then we have negative 7x minus 6 minus 14x. Now, here's what I notice. We could go ahead and combine those, actually, the minus 7 minus 14. So I'm going to go ahead and call that minus 21x. The reason I did that is because I'm comparing the left and right sides of this equation, and I'm noticing something funny. Could it be possible for this stuff with an extra 24 to be equal to that same stuff? No, it could not. So basically, if we added 6 on both sides, those would go away. If we added 21x on both sides, those would go away, and we would be left with a beautiful equation of 24 equals 0. And that is not true. That is what's known as a contradiction. So I'm going to go contradiction, and then the solution set would be empty. Solution would be there is no solution. So how were they wording it in the other problems? I think they had like empty set. Yeah, I'm going to go empty set for this one. So solution, there is no solution, so it's the empty set, which is just a bracket with fucking nothing in there. All right. Hope that made sense. If you have any questions, please let me know. This is 1 through 6, quiz 3 practice. Rock and roll. See you in the next video for the quiz 4 practice.